This is CosmWasm for smart contracts. You're learning the pieces of the CosmWasm framework on your way to being a smart contract engineer. I hope you did the whales only exercise. If not, go to heretolearn.xyz and check out the exercises there because you really have to apply this knowledge in order for it to stick. We'll talk about ENV today, just a quick lesson on ENV, which is the environment details of your contract's execution. And it is contract details like contract address, chain ID, information about the current block, including the current time, which is probably the most used aspect of ENV, since you often have to have things expire, vest, trigger, and so on. ENV is passed into all entry points since they all need access to things like what time it is, and ENV contains information about the chain, the block, the context of the execution. We have our block time, our block height, and our chain ID. We have the address for the current contract, the way for a contract to get its own address, which is handy in situations we'll talk about. And we have the transaction information, a little less handy, but we can get the TX hash, TX index, things like that. The query endpoint also takes the ENV. It doesn't take info. Info is stuff about the signer and funds being sent and things like that that aren't applicable to a query, since a query is view only, has no consensus, doesn't change state, doesn't spend funds. So even though we don't get message info up here, we do get the ENV, the environment information, so our query can also check information about the current block, or at least the most recent block. Although in this case, obviously, there won't be transaction information available to the query. The most common uses of ENV are block.time, which is a time-stamped object that you can process however you'd like. It's seconds since epoch, like you're probably used to in most platforms. And you can check that some tokens should be unlocked by now, for example, or check that a voting delay has ended. The vote had an end time, or like an expiration time or an execution time, something like that on it. And you can check whether that's ended or not. You can also use the contract.address to set the current contract as the owner of something. And we do this in a lot of cases where the current contract now owns an NFT. And maybe it's a treasury contract that owns some tokens. Well, in the case of an NFT, the NFT has like an owner field. What address owns me? And that could be the contract address owning an NFT. Learn is brought to you completely free because of our great sponsors. Neutron, enabling developers to build breakthrough applications and onboard users from anywhere. Osmosis, the premier decentralized crypto exchange. And Obi, the smart new standard for asset management. If you want to become a smart contract developer through this lesson and others like it, head to heretolearn.xyz for uninterrupted course videos, coding exercises, and feedback directly from experts in the industry. You can also set the current contract as the owner of itself during instantiation, for example, where you're instantiating the contract and it owns itself so that it can handle its own migration. You can wrap migrates, runs a contract or whatever to migrate it and not have to deal with the actual code admin itself at a lower level and all the pains around that. You can have multiple people that can migrate, for example, rather than just that one code admin by having a contract be its own code admin. And then you can wrap the migration and have a bunch of logic in that. And you can also have a new contract created by the current contract. And you might want the current contract to own that one, especially if you wanted to be able to migrate it later, for example. So contract A actually instantiates contract B. Maybe it's a user-specific account contract, or it's a factory contract that creates tokens or NFTs or whatever. You can also have a contract instantiate another contract, a factory contract, for example, token factory, NFT factory, user account factory, pool factory for a DEX, for example. Contract can create other contracts. And in that case, you might want the contract to own the contracts that it creates, to be the code admin, so that it can handle migration of all things, for example, like a wrapped migration of all the DEX pools if it needs to push a code update, or some other reason that you want a contract to be the owner of all of the contracts rather than setting it to some like seed phrase account, for example. Code admin becomes a little bit less restrictive, since usually it has to be a single address or a multi-sig address. you can make it a contract address. And to get the address of the current contract you're running, whether you're instantiating it or executing it, you call env's contract.address. But much more common than contract address is deadlines, timeouts, and time locks using block.time. You have a function has deadline passed, really simple here, where I pass in my env. I'm not changing it. I can pass it in by reference. And some deadline. Maybe the deadline is stored or calculated or whatever. It's in a proposal. It's in a vesting schedule. And I return whether or not the current time is greater than the deadline. So if the deadline has passed, then this will return true. If the deadline hasn't passed, it returns false. Simple stuff. The print line is really just to add some more clarity into, I guess, to show you the seconds function, that you can convert this to seconds or handle it in some other way, however you would handle a time stamp. So you're going to use this directly for vesting in the env exercise called vesting. We're not going to deal with contract addresses since we haven't done multi-contract operations yet, but you will be taking some coins and making them so that they can't be moved, can't be claimed or withdrawn until a certain deadline has passed. If you want to write unit tests, then you'll have to learn how to mock this so that you can pretend it's a time in the future. And that's pretty easy to do, and that's covered in the very next video, unit tests. But before you write those tests, go ahead and just give the actual code a try in the vesting env exercise over at heretolearn.xyz. If you're watching somewhere else, go there for the CosmWasm learning book, a lot of helpful supplementary materials and exercises for each and every video so that we can integrate these concepts and make them just second nature as we write CosmWasm smart contracts.